Morning, Jackson. Okay, it's 8 o'clock. It's time to start talking. Today we do 1.6. And then on Monday, we have our exam 1. I have let me see. I have a review for y'all. I actually have it on my, on this little whiteboard app right here. And so tonight I'm going to go through and I'm going to answer all the problems. So all the solutions will be down, if you just kind of keep scrolling like that. It's just the easiest way I could think of to actually do it at home and be able to actually email it to y'all. And the actual review is right there. And I'll send y'all that tonight. With the weather days and stuff like that, we weren't actually able to have a review day and stay somewhat on schedule. So today we'll do 1.6. Monday's the exam. Make sure you have a pencil, and y'all could have that 3x5 note card with formulas or steps or anything like that on it. Okay. If you have any questions about it, y'all could just email me. There'll be 20 problems, all worth 5 points. And then a bonus problem at the very end, which is usually pretty much the easiest question you could ever be asked in your whole entire life to get 5 points. Okay. Okay. So we're gonna go get started. What we're gonna do today is rational equations and radical equations. The name of this actual homework or section is other types of equations. Not very unique. Other types of equations. I'm not even gonna lie. These do get kind of crazy because I don't really know if they do it just to make them seem complicated or difficult, but they are actually a level of difficulty worse than what we have seen. The rational equations are going to be the equations where we have to have a least common denominator, because rational means ratio, which means a fraction, right? So we're going to have fractions in an equation, and we need to actually find a way to get rid of that denominator. So with the common denominator, every single denominator in your equation will cancel. And then there's just a lot of distribution, and then you solve for your actual unknown variable. With the radical ones, when we get to it, I'll show you, there's kind of a shortcut, but those also could get pretty complicated. I don't think I know for a fact we will not have a complicated rational one on the test. It'll be one of the more easier ones. And then hopefully if y'all have on your note card the steps for the radicals, those won't be complicated as well. But these rationals do get crazy, so kind of just write your notes. And I do have homework examples as well. So if we have time, I'll do those. Okay, so the first kind of examples that we're going to see, they're going to be rational equations. Okay, and these have one or more rational expression, which is a fancy way of saying a fraction in an equation. And what we have to do to actually be able to solve these is we need to multiply everything by the least common denominator. Denominator. I don't know why I can't spell that today. which is also an LCD, like that would be the shorthand for it. And our goal when we do that is because we want to cancel the fractions. We're actually canceling the denominator. We're having trouble refreshing this component. I'm just going to say that we're canceling the fractions because we're going to go from having one or more fractions in an equation. We're going to use the LCD, multiply everything by this LCD. And then what ends up canceling is the denominators. And so essentially we just got rid of our fractions. Now we just have a linear equation. And then there's just a whole bunch of distribution. And then you solve for your unknown. Wanted to thank someone for leaving me an early Christmas gift, but I think I know who did it and I don't see them in here. Maybe it was another class. Okay. So let's go and do this example. Okay. The examples will just say solve. They're not really going to tell you hey, this is a rational equation, find your LCD, multiply it. You're supposed to just be able to look at the certain equations in their forms and then know what to do. So that's why a lot of the directions just say solve. Okay. So it's our first example. Like I said, there's going to be fractions, and this is how this one starts with a fraction. In our numerator, we have 2x plus 4. In the denominator of this first fraction, we have the number 2. And then we're going to subtract from this another fraction. And we have 3x. And then in the denominator, we have x minus 4. And we're going to set this equal to x. So I know we haven't really seen them in this class, but we have seen fractions before. And in our fractions, there's just numerical values in the denominator. Here, the difference is going to be that you actually have variables in the denominator. And so that's kind of what sets this apart from just a normal fraction in a equation that you're solving. So what we need to do, first I'm going to tell you about the LCD. I'll stick with the green, but I really like the blue. Okay, so our LCD is the, let me say, the product of all the, and then in quotes, I'm going to say unique denominators. I really had to smush denominators there at the end. Another way of saying it is that it would be the smallest value that all of the denominators can equally divide into. But if we just say right now that it's going to be the product, which means things are multiplying, right, of every single unique denominator, then I think that right there should kind of help explain what we're going to use. For this problem, our LCD is going to be, I'm going to delete things after I kind of do it, but 2, this is a unique denominator that I have not written yet for the LCD, so I'm going to write it. Then when I go to the next denominator, I have x minus 4. That's also unique. I have not written it yet, so it's going to be a part of my LCD. Okay, right here where it says product, it means they all get multiplied together. So I'm I need to make sure that I leave that in those parentheses. The other term on the right-hand side, it's not written in a fraction form. Technically, its denominator is 1, but that doesn't change anything. So right here, this 2 times x minus 4, that is the LCD. This is what we call the least common denominator. This is actually going to be exactly what we need to cancel both of these things in the denominator so that we can then solve it in a linear fashion. Okay, and this is more of a simpler example, but just kind of understand whatever you see that's unique, write it once, then multiply everything by that. Okay, so let's kind of go ahead and start multiplying everything by this LCD. I need to scoot this up a little bit. Okay, so I'm gonna have 2 open x minus 4 close, and I need to multiply it by this first term, and I am putting it inside of like just big ugly parentheses. And then I have the minus sign to open x minus 4. I'm going to multiply it to this other fraction that I have. And do not forget, it said to multiply everything by the LCD. So that even means the stuff on the other side of the equal sign. So we have 2 open x minus 4 close, and then we have our x. So you find the LCD, multiply everything by the LCD. So I kind of just rewrote the fraction, adding the LCD next to it, and I put everything into parentheses. Now, whenever you do multiplication, as long as it's all multiplication, like on the top and on the bottom, what you can do is actually like cancel things or like reduce them. And so the reason why we use this LCD to cancel our denominators, I'm going to erase this after I write it, but technically this whole LCD could be written over 1, right? It's like this is a fraction multiplying this fraction. And if you're doing this multiplication, you can cancel things. Whatever you cancel on the top, you have to cancel on the bottom. I keep it even, right? So if I kind of think of it that way, I see that I have a 2 on the top and I have this 2 on the bottom. Those can cancel. Those just went away. So if you notice, this fraction that's in this bigger parenthesis is fixed to not be a fraction anymore, which is what my goal was. What I have left is just the multiplication of this and this. Okay, then I'm just going to go ahead and scoot over to this other side. I'm going to cancel whatever I have on the top with whatever matches it on the bottom. This x minus 4 cancels with that x minus 4. Okay, once I kind of show myself what's canceling, now I can rewrite the problem with just what's left. And so what I would have is just this x minus 4 times this. Okay, because what I have marked out in green is gone. I did that for a reason. That's what the LCD does. It gets rid of whatever's in the denominator. Okay, so I have x minus 4 times 2x plus 4. That's what this whole first thing just turned into, because that LCD did its job and canceled what's in the denominator. Okay, and then don't forget right here, this was that negative sign or like a subtraction sign, minus sign, whatever you want to call it. Okay, that stays just like that. And then if you look at this second term that was in this equation, this 2 was not canceled and this 3 was not canceled. Those 2 terms in the green, those literally went away because that's what the LCD does. So I'm going to now just have 2 times 3. And yes, you could have just written 6. If you see, it's just 6. That's not a big deal. Okay. And then I know I'm kind of scooted over a little bit, but now I'm at the part of the problem where I'm just at my equal sign. And over here, I didn't actually have a fraction. It just has to be multiplied by that LCD. But if you notice, like there was nothing in the denominator to cancel. So now I just have those 3 things multiplying each other. I'm going to tell you right now what I would do and what I'm going to do. This 2 right here and this x, I'm going to write them next to each other and then put what's in the parentheses. Okay, so if it does confuse somebody, that's what I'm doing. I'm just rewriting it in like a more of a simpler way, because it doesn't really make any sense to have a 2 and then that parenthesis and then an x on the other side. Okay, those actually can be already multiplied together. And then now what I have is just a linear equation, which we've solved multiple times before. We're going to do a whole bunch of distribution, combining terms, and then you solve for your unknown variable. That kind of makes sense. Okay. So this basically ends up being FOIL right here, right? Because I have x times, let me do this, y'all. I have x times 2x, which is 2x squared. Then I have x times 4, which is going to be 4x. They're both positive, so that multiplication results in a positive. And then I have this negative 4 times a 2x. 4 times 2 is 8. Signs are different, so it's negative. And don't forget that variable. And then lastly, I have 4 times 4, which is 16. those signs are different, so it's a negative 16. And then I'm now at this part right here where I have the 2 times the 3 and that negative sign. 2 times 3 is 6. They have different signs, so it ends up being a negative 6. And then equals, and then we could do this distribution right there. We have 2x times x, so it ends up being 2x squared. 2 times 4 is 8. Signs are different, so it's negative, and then don't forget that x variable right there. And then you really just kind of have to look and see, is there anything that has the exact same variable and the exact same exponent? Because if so, you can combine those. If not, move on to the next variable. If nothing just has 1x, which there actually is, you move on to just the numbers and you kind of work on one side. And then once you get it simplified as much as you can, that's when you start moving things around. Right here, I noticed that like this 2x squared. Yes, y'all, over here, there is a 2x squared, but I'm not working on both sides simultaneous like that. You work on one side. Okay, a lot of the times, just a lot of broken math will happen because y'all see that they are alike. Okay, I'm literally only working on this side first, and then I'll look on the other side, and then I start moving things. Okay, when I do this on the left-hand side, there is nothing else with a squared. So that 2x squared, I just rewrite it. And then right here, I noticed this does have an x term. It's a positive 4x. And then there's another x term. It's a negative 8x. Signs are different. So what you do is you subtract, keep the sign of the larger, keep the variable, keep the exponent. Or just look at it in your calculator, put the positive first. If you do 4 minus 8, you'll get a negative 4. And then when you're adding or subtracting variables, you just keep and keep. Then I also notice that I have this numerical value that is just a numerical value, no variable, and another one that is also just a numerical value with no variable. And so, sorry, I did things all kinds of different on here. Did I do a mistake? Is someone not catching me that I just caught? Okay, thank you. Do you see it? Tell me what it is. Is it the X with the 3? Say something. I say something. Please say something right here, y'all. Look. Okay, so do you see how whenever this problem started, right there, there's a 3x. Whenever I was like, because it's hard to talk and think and write and then like think about what else I want to say, like I'll mess up. I am superhuman. Whenever I rewrote, like, hey, multiply everything by the LCD. Look what I left off, was that X, which it's not like the worst mistake in the world. I could have broken math more, but what happened is right here, that should have an X right there. Y'all see me? There should be an X there, and then an X should carry to right here, which also means now right there, there's another freaking X. Okay, when I looked up, I just didn't remember getting to this last semester. I remember there being another term. So what happens here is 2 times 3 is 6. Signs are different, so it's a negative 6. And then don't forget that X. So do y'all see how I didn't have to go too far back, because if I can take this off right here, we had actually just did this part right here, right? And I said there was nothing that had an X squared except for this term, so I just write it. Okay. Then when I start looking, what all has just an X? It's the 4, the negative 8, and the negative 6. Okay. So this one right here is also going to be included in that. And so if you do that math, I would say, trying to think the easiest way. I have my calculator, but I like to do things in my head if it's little numbers. If I did 4 and 8, signs are different. I would get 4 and it's a negative 4. The negative 4 and negative 6 signs are the same. So you would add them together, which would be 10, and then keep their sign, keep the variable. If you didn't do it that way, what you could do in your calculator. That's the only thing that's bad about writing on here is I don't have a calculator to show y'all. You could do like in your calculator, the 4 plus the 8, and it'll show you the -4. And then while that -4 is still in your calculator, you could push that plus button and then the little negative button, the 6, and then it'll tell you the -10. It was like there's 3 different numbers kind of being combined there. Okay. If you did have your calculator and you messed around with it to see what you got and you don't get -10, y'all could tell me and I could help you. Okay. Okay. So sorry for that mistake though. Now looking, I see that I do have this -16. Nothing else is just a number. And so I just write -16 equal 2x squared -8x. Left-hand side, nothing is alike or like the same type of term. And on the right-hand side, the same. So now I could start going ahead and moving things around. Okay, I am going to move. Technically, it doesn't really matter. I'm going to move from the right to the left. And what I notice is those will cancel. And what I'm left with on the left-hand side is -10x, -16 equals, those canceled, -8x. And I did that personally because just me in my mind, I'm always moving x's to the left because I always try to get to like x equals a number. And so I just my habit. Okay. If y'all did it the other way, you're still going to get the same thing. Okay. And so now, personally, I don't want to move this one yet because I know that that would make it be a 0. So I'm kind of wanting to move the number. If I did this, it would move a 16 over here. I have -10x, those went away, equal -8x plus 16. And then now I would move that x. If you moved that 8x first and you got a 0, just don't think that you did anything wrong. There's like 10 different ways to Sunday that you could do all of these problems. Now I move that 8x term. I notice that I have 10 and 8. They're both negative. So what you do is you add them together, you keep their sign, and then you just keep the x. Here they cancel. Here I have 16. Have I broken math yet? Because I feel like I did talking. Now I'm gonna be gun shy all day long, thinking I mess up everywhere. Oh, y'all. Did you see me, Isaac? I'm gonna have the worst day possible because once I get in my head, y'all, I can't math to save my life because I mean I'm okay with it, but it messes me up. This is 2x and this is 16. Y'all don't hate me. I love you. Oh, I gotta get out of my head. And then divide by 2. Divide by 2. It's a -2. And you get x equals 16 divided by 2 is 8. Signs are different, so it's negative. Did you get that? No, you're gonna be the one I refer to. Okay, we have like 27 more problems to do, so I'll correct myself. We're gonna do one that's pretty much just like this. And that'll be where, let me see, hold on. No, I'm just kidding. I was being facetious. He's like, I just can't. I know. No, wait, because this next one's kind of worse. I'm not even going. Okay. So, but no, y'all, seriously. I have to have like a little baby pep talk in my head right now. Oh yeah. Okay. Let's do this other example. So we're going to have a large fraction bar. In our numerator, it's just the number 3. In our denominator, it is x squared, a positive 2x, and a negative 24. And then we're going to add to that. It's also a fairly large fraction bar. Numerator is a 5. Denominator is x squared plus x minus 20 equals large fraction bar, numerator 5, denominator x squared plus 11x plus 30. Okay, so with our LCD, the fact that it's like a product of all the different denominators, we could also say that like it's a product of factors. And if you just took these 3, they're trinomials, tri meaning 3. If we took all 3 of these trinomials and then just set them next to each other, they would only cancel themselves, and it doesn't really do anything else for the problem. What we need for our LCD is for all of the unique denominators that we use to only have the highest power to be 1. You will literally go down a rabbit hole if you try to just use these the way that they are. And so if we look at each individual denominator, what I notice is that all of their leading coefficients are 1. And so I'm just going to use that shortcut method to factor it into linear factors. And then you're going to notice that you don't notice now, they actually do end up having a lot in common. And when you write down each unique denominator only one time, the majority of everything's fixing to just completely cancel. But doing it in the way where you just want to do it from scratch right now without breaking them apart, it literally will end up just having you go around in circles. So if we use that shortcut method, I know that the variable I'm working with, why did I change back to purple? The variable I'm working with is x. And honestly, y'all, it's one equation, so it's all x's. Just to be honest, you could go through and fill them all out. Whichever one has a trinomial and whichever one you can break down like this, that's our starting point. The parentheses, the x's. And then now we look at the very first one on the far left. What is the number that multiplies to give me 24? And it'll be a negative 24. And the two numbers also combine together to give me a positive 2. 6 and 4, very good, Maria. So it doesn't matter which way you write them. 4 and 6, 6 and 4. If my 2's positive, which one's going to be the positive one? The bigger one, right? The bigger number, because when I combine, if the signs are different, you subtract, keep the sign of the larger. So 6 is positive, 4 is negative. I'm done with this right here. Now do the other one. 4 and 5. Which one's positive? Which one's negative? 5 is positive, 4 is negative. Very good. Okay, over here, what's this one? Yeah, did you say 6 and 5? Yeah, 6 and 5. And then is there a negative, or they're both positive, right? Because if I do 6 times 5 and they're both positive, I get a positive 30, and then 6 plus 5, both positive, give me a positive 11. Okay, now we can create our LCD. And I know it doesn't make sense right now, but everything's fixing to cancel, and then you're actually able to solve it much easier than if you had done it with the other denominators. In all actuality, you can't solve it with those denominators. So just probably don't try. Okay, so we factored those denominators into linear factors. Now we can find the LCD. Our LCD is going to be the product of all unique denominators, meaning don't write anything more than once. Starting from the left, do you notice how that denominator is those two factors, x minus 4 and x plus 6. Okay, I haven't written them yet. That makes them unique. I'm going to write them. Go to the second fraction. That fraction's denominator is made up of the factors x minus 4 and x plus 5. I've already written x minus 4. That's not unique. I'm not going to write that one again, but I am going to write the x plus 5. And then whenever you look at the last fraction, both of those individual factors, they've already been written, right? So I'm done. It's these three right here that make up my LCD. Now I multiply each of these, fractions by this LCD, and then what needs to cancel will cancel. But you'll notice two things are going to cancel from the top and one thing's going to remain. That's why trying to do it in the original form wouldn't have worked. Okay, so let's do that. I'm probably gonna have to zoom out, y'all. Oh, ow. Stop. Okay, let me cancel this. I wonder if it'll let me like copy and paste this. Is that copy? Maybe. Probably not. Just never mind. Yep, nope, I'm gonna have to write it. Okay, so I'm gonna write that whole entire thing. Y'all, for my room's sake and for y'all's as well, you could write them on top of each other. You could write them kind of staggered. They don't have to be in a complete line. Okay, we know that all of these are being multiplied together, and for just the length of your paper, it's something that you can do because as soon as you write them, you can cancel them. Okay, there's another way you can do it. If this is something that does make sense to you already, you could write this once outside of the bigger problem and then just cancel what cancels, but don't let that confuse you. Let's do this. X minus 4, x plus 6, x plus 5. Okay, and this is going to be times 3 over x minus 4, x plus 6. And then it's plus all of this again. Times this one right here, that middle fraction. It is 5 over x minus 4, x plus 5 equals all of them again. Five over x plus 6, x plus 5. Once you see that what happens is some cancel and only the one that doesn't cancel remains, you can jump straight into that linear equation. But if you do not see that, then I would write everything and then cancel it and then bring down what remains. Okay, but right here, I'm just moving up just a little bit. My x minus 4 and my x minus 4, those cancel. X plus 6, x plus 6, those cancel. The first thing that I'm going to write that starts my linear equation is this x plus 5 times this 3. That's the only thing that remains. Okay. And then right here, x minus 4, the x plus 5. This is the only thing that's going to remain. And don't forget that plus sign. And then lastly, down here, the x plus 6 and the x plus 5, that's what cancels. The only thing that remains is the x minus 4 and the 5. And obviously, don't forget that equal sign. So again, if you do see that there's one thing that remains in the numerator that doesn't get canceled and it changes for every fraction, and you can just jump straight into your linear, then go ahead and do that. Okay, right here, I have what? 3 open, x plus 5 close, plus 5 open, x plus 6 close, equal 5 open, x minus 4 close. That's how you solve this problem. is by now doing this linear equation. It is going to be 3 different sets of distribution to start off. 3 times x is 3x, 3 times 5 is 15, signs are the same, so it's positive. 5 times x is 5x, signs are the same, so it's positive. 5 times 6 is 30, and it's positive. Have our equal sign, and then 5x and a negative 20. I'm moving up and kind of not showing what's up there, so if y'all need me to, just tell me. And then combining terms, I have a 3x and a 5x, and I have a 15 and a 30. The 3x and the 5x make 8x. The 15 and the 30 make a positive 45. And then on the right-hand side, I have a 5x and a negative 20. Just have it. I move my x's first. What am I doing? See, it's always better when I don't think. If I start thinking, I start messing things up. There we go. So if I do my 5 and I move it, it's negative 5 on both sides. 8 minus 5 is 3x. And then plus 45 equals, those cancel, negative 20. And then if I move that 45, that ends up being a negative 45 on both sides. Negative 45. I get 3x, that cancels, equals a negative 65. There's starting to be a delay. I can tell because it's making my handwriting look crazy. And then if you try to divide this by 3, it actually in your calculator would give you a decimal. If you hit math, enter, it'll turn it back into a fraction, and you'll see that it actually cannot be reduced. Our x is just negative 65 over 3. If it tells you to check, I probably wouldn't recommend checking, especially if it's a big ugly fraction. Whenever we're fixing to do the radical ones now, you may get 2 answers when you do the radical equations, and those you kind of should check because you have to make sure that it does make the equation true. With the rational ones, it's asking you to check because we have variables now in the denominator, and it's wanting to know if this answer would cause this equation to have a denominator that would go to 0, and we know we can't divide by 0. I've kind of noticed that the majority of them all end up being, I guess, okay. But if it does end up telling you that that's not your answer, then that means that it did send that fraction to 0, like in the denominator. And so it ended up not having an answer, even though you would go through all that process of solving them. Okay, let's do these, this radical one. And actually I have 2 examples for the radical equations. I'm going to tell you what the steps are first, and then we will go ahead and solve them. And then that'll be it. We will be done for our exam 1. I know there has to be something wrong with me because this is what I enjoyed when I was in y'all's seat. I know. I hear myself say it all the time. Definitely a masochist, that's for sure. Okay, so whenever we solve our radical equations, there are a few steps. Okay, so what we want to do is isolate radical term. So whatever it is that's underneath a square root or cubed root or fourth root or fifth root or seventh root, whatever they show you on the homework, that's what it is to be like a radical term. Okay, and then we're going to raise both sides of equation to the power of the, I'm sorry, to the power of the, of the index on the radical. And I'm fixing to show you what that means right now, because you want it to be the same. So you don't have to write this right here, but whenever we first did like the complex, we were really only dealing with square roots. And I told you that if you have something being squared and you took the square root of it, that what ended up happening was it canceled and we just were left with what was underneath the square root. Okay, that was just a very simple way of looking at the rule because I knew we were only dealing with square roots at the time. Now it gets a little bit more complicated because instead of just being squared, they'll give you an example that's a cubed root or a fourth root or a fifth root or a seventh root or any number that they want to make it. So whenever you see, thank you. Whenever you see a radical and it's called an nth root. Literally, it means number, like whatever number is here. It could be a 2, a 3, a 4, a 5, a 6, a 7, a 8. It could go up as high as they want to go. Whatever number is there, whatever's underneath the radical, if it matches it, you end up getting just an X. And then there's another variation of the rule, which just states that whatever your radical is, if you raise it to that power, you end up getting X. So right now that doesn't make any sense, but what it's going to be is if you have a problem and there's a 3 right here, right? What we're going to do is we're going to raise it to the third power and it makes it go away. It makes it cancel. Okay, that's all that's saying. As long as those numbers match, we have the ability to be like, hey, this is like a little shortcut and I could actually make it go away and just give me what's underneath that radical. Okay, that's what all of those right there are saying. So, so we're going to isolate whatever is in the radical term, and then whatever my little ends are, whatever root I'm dealing with, that's what it's really called. The index is like a root. Whatever root I'm dealing with, we're going to raise it to that power. So there's that shortcut so it can cancel. And then now what I do once I've done that, there's like one, we would just solve it, right? But there's one little step right here that we need to put, and it's if radical still remains, we have to repeat those steps again. If radical still remains, repeat. Okay, if a radical does not remain, basically all you notice is that you have a linear or a quadratic. I'm sorry, I don't know why I said linear. you end up usually having like a quadratic equation in some kind of way, shape, or form. Yes, yeah, like to show you more or to go that right here, yep. Yepers. It's kind of like, it's just like two different variations of the rule. It's just different ways of seeing different things. Either it's raised to a power and you take the square root of it, or you raise a square root to a power. So you end up creating like this equation that you can more easily solve, and it gets rid of those radicals. But if you notice, hey, I already did this step, I already isolated, I already raised it to a power, there's still a radical, then you do the exact same thing again. You raise it to another power, and there will be probably one in your homework that does that. If a radical does not exist, what you do is you are just going to solve it for your variable. These you do need to check your answer. So if I have this problem that they give me and I end up solving that x equals 2, you take that 2 and you plug it back into the original. You do the little bitty steps that it takes, and it'll be like 25 equals 25. If that's what happens, then yes, your x equals 2, that's your answer. If it ends up giving you a contradiction, then that's not your answer. Okay. Let's do, how bad is this example? This example is pretty bad. It's a math class. All the examples are bad. Okay. Let's do this one. I want to kind of pick the one that I know I have straight from your homework. I'm dealing with a really bad delay right now. Tell me, Christian, if you need me to go back down again, okay? Okay, let's do this one. I wish someone had their homework pulled up, because I'm wondering if they give you one with multiple radicals in it. 8:46, 9:15, 30 minutes. Okay, so let's do this first one right here. And then I'm going to have to show you this other one. 2 more actually. So say we have the square root of 5x plus 95. And then close the actual radical. I really just don't know where this one's going, but we're about to find out. Right next to it, subtract 9 and have it equal to 3x minus 2. I wrote this one down from your homework, completely 100% from it. It's not from my notes. Okay, so let's solve it. The first step was to isolate your radical term, whatever it is that's in a radical. Whether it be square root, cube root, fourth root, fifth root, that right there, that's my radical term. Isolate means to get it alone. So if I get this alone, it's taking forever. To get this alone, what I would do is I need to move anything that's around it away from it. So this 9 would need to be moved to the other side so that that radical term is by itself. And I would have the square root of 5x plus 95. Those are going to cancel, which is what I wanted, equals 3x. Signs are different, so I subtract. I wrote a 7, it's just not written, it has not written it yet. Okay, so I subtract and keep the sign of the larger. So that was the first step, was to isolate the radical term. Then it says to raise both sides to the same power as the index. The index is right here. Whatever number you see here, that's the index. If you don't see a number, it's implied that it's a square root. So the index is 2. Okay. So if it says to raise it to the power that matches the index, both sides, I'm going to raise this left-hand side to the second power. And then I'm also going to raise this right-hand side to the second power. On the left-hand side, I did that for a reason, because it's a shortcut, and now I can like cancel that radical, and I'm only left with what's underneath that square root. Okay. On the right-hand side, I've just now created needing to do foiling, right? Because now I'm going to make a copy of that binomial. So over here, did that for a reason. That literally cancels that radical. I'm left with 5x plus 95 equals. Here, I actually have 3x plus 7 twice. And I will need to FOIL that out. But now at least I've gotten rid of that radical symbol and it's just linear. Okay, now it's kind of gone back to like 1.1 type of work. And so left-hand side, I can't do anything with because nothing's alike. Right-hand side, I think I might be able to just FOIL this. 3, it's gonna be 9x squared, 21. X is gonna be a positive 42x and then a positive 49. I just FOILed that in my head. 21x, 21x. 7 times 7 is 49. I skipped a step there. Okay, just so everybody knows. Okay. So I need to start moving things around. If, and I know this goes against everything I always say, but if I move this term to the left, it's going to end up being negative. And because it's squared and it kind of tells me that I'm dealing with a quadratic, I don't want that x squared term to ever be negative. I actually need to move these to my right. Okay. So, and I'm going to kind of start bunching things together because there's 2 more examples I want to do. All right. I'm going to be moving those. This is where the 5x is moved. This is where the 95 is moved. That cancels, I'm left with a 0 equals 9x squared. This is going to be a quadratic formula. What is that? 37. 42 minus 5 signs are different. Subtract, keep the sign of the larger. Don't forget your variable. And then I don't think I could do that one in my head. 55, 4. I put the positive in first, 49 minus 95, 46. I said 44. Minus 46. And then we've set up a quadratic formula. Yeah. Does anybody have their laptop? You want to tell me how many problems are on the homework while I start all this up? Do you mind? Please. I'm just curious. Because in my mind, there should not be very many of these if they're going to require this much work. I'm continuing to solve. I'm just doing it in a quicker manner. I can do it better when I don't talk. If there's like 10 problems, that's really not bad because it's probably like a handful of each. Anything more than 10 is going to be a lot. Do you see it on there? What I've done so far is just put everything into the quadratic formula. And now I am actually solving it. Times 9 times 46, 1656. This should end up being a perfect square. Y'all are killing me, Smalls. That's a whole ass like 3 minutes that went by. You could have asked me a minute ago. Could you look on the homework and just tell me how many questions are on 1.6? See, that's a lot. Do me a favor, go to, if there's 15, go to like 11, 12, like the last ones. Tell me if you see problems that have 2 radical signs in them.
11 and 12.
Yeah, like just like the last ones, because it's going to start with the rational and it should be like kind of fairly easy to a little bit harder. And then about in the middle, it should start the radicals. And then like, obviously the last problem is going to be the hardest one. I'm wondering if it has one
11 is
that has,
negative, or hold on, 3 plus square root z minus 4 equals negative square root z plus.
so there is one with 2. Okay.
And then
Right, so it changes. Does it have the,
And then the
it has
one
two
after
radicals
that,
in it though, like
has
two?
has like the little number like right there.
Okay, yeah, that was like this. You'll see a homework problem where it's like this. And there's something underneath here. What that's telling you is raise both sides to the 7th power. Whenever you raise this to the 7th power, that completely goes away. And now you just have what was underneath that radical. Okay. But yeah, time wise, like, I mean, we only have so much time and like they throw so much at y'all. I have been talking and doing this one right here, the quadratic formula one. I noticed, thank y'all. I noticed that it had to be a quadratic formula because this leading coefficient was a 9 and I couldn't divide everything by a 9 to turn it into a 1. So I identified my A, my B, and my C. I plugged it into the formula very softly because I'm just trying to get it done. And then whenever I did actually combine those numbers underneath the radical and then took the square root of it, I got a whole number, which means it is a square root. And then right now I'm going to see what my two values are. And then I'm going to show you how to check it because I think only one value is going to end up working. And then the hope is that I can do, yeah, I'm just gonna have to pick one, probably the one with the 2, because I have to show you how to do that. So let me do this. Negative 37 plus 55 divided by 18 is 1. That's going to be it. Negative 37 plus a negative 55 divided by 18 is a negative 5.11. It's going to be a fraction. Okay, this one right here, I can tell you right now. Let me turn it into a fraction. Don't write that right now, Isaac. That one ends up being, I turned that decimal into a fraction. It's a negative 46/9. Now, because I got 2 answers in these radical ones, they'll tell you to be sure to check your solutions because not both of them will always be the answer. 2 of them could be, neither of them could be, or just one of them can be. And what it means by check your answer is, I hate this being thin. The original problem was what? Okay, so check, there we go. X equals 1. It was the square root of 5 times 1 plus 95. That was all underneath the square root. Minus 9 equals 3 times 1 minus 2. So what's 3 times 1 minus 2 is just 1. So it's saying that this left-hand side should equal 1 and both sides should equal it. So if I do this, 5 times 1 is 5 plus 95 is going to be the square root of 100 minus 9 equals 3 times 1 is 3 minus 2 is 1. What's the square root of 100? 10 minus 9 is what? I'm writing it, y'all, I swear. And what I end up getting is 1 equals 1. Okay, and because yes, that's true, the answer I plugged into it is a solution. I'm just going to tell you right now, if you worked with or tried to do the 46/9, it ends up not working out. And you would be able to kind of see pretty quickly in your calculator it didn't work out. We still could check it if you wanted to, but I'm not even going to lie. On the homework, just type in 1, and if it says yes, you're right, that'll keep you from trying the other one. If it says that you're not right, then type in both, and it ended up being that ugly fraction as well. But there's a way to keep from having to do that ugly fraction. Okay, I've got 15 minutes to do this very long, complicated problem, which is like the ones at the very end of your homework. Okay. On the test, I'm not going to give you one that has 2 radicals, just as a heads up, even if there's one in the review. But to be able to do your homework, like I need to at least explain how this works and why it works. And this one little step. So the metaphorical rabbit hole I always talk about, none of y'all end up under. Okay, so last example. I cannot be that thick. Okay, so it looks like this. It's the square root of x. And then we're going to subtract the square root of x minus 17. And we're going to have that set equal to 1. The rules remain the same. Isolate, raise to the index to be able to cancel. If a radical remains, repeat your steps, and then eventually you get to a point to where you can solve. These end up being complicated because there's 2 of them, and we're fixing to have to FOIL with radicals. Okay, and there's this one little rule that could be complicated, but isolation means to get the radicals alone. Right now, these radicals are not alone. What I notice is this radical is positive. I don't want to move that one because it would make it negative. This one is negative. So I actually want to move that one to the other side. And then essentially, because I have 1 on either side, they're isolated from each other. Okay. And that ends up being what we need to do, is we need to actually move, this one over here. And then just as a heads up, put it in front of the numerical value. I hate writing in this thin marker. Okay, so I have the square root of x equal to the square root of x minus 17 and plus 1. The radicals are isolated from each other. This is what you need to do whenever you have 2 of them. Now it says to raise both sides to the index. Okay, if I raise both sides to the index, there's no number here. It's an implied 2. So if I square this, I also square these. You square them together. You've just now created like a binomial, which means I'm fixing to have to copy them, which means I'm fixing to have to FOIL them. Okay, this is where these could get complicated. Left-hand side, this goes away because we just used a rule. Right-hand side, it does not go away. Okay, because it's 2 different terms underneath or inside of that parenthesis. So whenever I do this, let me go ahead and rewrite it, copying that binomial. Here I have x is equal to open square root of x minus 17 plus 1 close open square root of x minus 17 plus 1 close. Okay, left-hand side is just x equals, let's FOIL. Okay. So I'm going to write a rule kind of maybe right here in green. If you, we're using the same rule. Do you know how I keep saying if you have something in a square root, right? And then you square it, what happens? It just becomes what's underneath the square root, right? That's what I'm fixing to use right now. It just looks different, but I promise it's the same thing. Okay. It's taking something that's inside the square root, squaring it, and then it ends up just becoming what's underneath the square root. So let's do this. If I take the square root of this term and I multiply it to the square root of the same thing, all I did was square it. So the only thing I have to write, the only thing that remains is what's underneath the square root. Okay, because all I did was take this, copy it twice, but what's that rule say? That it goes away, right? Okay. That's like that's literally the most complicated part right there. That's it. Let me erase all this right here at the bottom. Okay. Now I take this and multiply it to 1, which means it is just, this delay is killing me, Smalls. It is just going to be plus the square root of x minus 17. Now I do 1. times this, which is just a positive x minus the square, I'm sorry, x minus 17 underneath your square root. Thank you. Oh, I think that one works. No. Okay. And then lastly, 1 times 1, which is just 1. Okay. Now, it doesn't look like it, but I have like terms on the right-hand side. I actually have 2 sets of like terms on the right-hand side. I have a negative 17, which is just a numerical value, and a 1, which is just a numerical value. And I also have these right here. Okay, they're literally the exact same thing, and there's 2 of them. So the number 2 is going to go in front of them because it's kind of like this radical is being acted on as like a variable would, right? If that was just x and that was just x, it would turn into 2x. And that's the same thing we're going to kind of use right there. So what we have is x equals this x right here on the right-hand side is alone. Negative 17 plus 1 would be a negative 16. I'm going to actually put this in the first, like in the front. Okay. What I'm going to do is plus 2 square roots of x minus 17. And then here I'm going to do a negative 16. Okay. And then now I'm trying to solve, I'm so sorry. And then I remember I am trying to solve for my x, but the step was to isolate, raise to a power, and if a radical still exists, repeat, right? A radical still exists because this right here has a radical in it. So I need to repeat the whole thing again where I isolate this one, and then we'll be able to solve it. Okay, so if I isolate this one, I need to move everything away from it, right? So if I move everything away from it, the first thing I would do is to move this x. That's going to make this cancel. I get 0 equal, those cancel. 2 square roots of x minus 17. And then on the outside of that, I have minus 16. And then now what I would do is add 16 to both sides. And yes, you could have moved the 16 first, whatever you wanted to do. So what I have is 16 equals 2 square roots of x minus 17. And then now what I notice, to isolate that radical completely by itself, it's being multiplied by 2. I divide both sides by 2. Like this. 16 divided by 2 is 8. Those signs are the same, so it's a positive 8 equals, those cancel. I'm left with the square root of x minus 17. I did all of that just to isolate that second radical. Now I raise it to the power of the index, which is squared. What I do to one side, I have to do to the other, just like this. Left-hand side, 8 squared is 64. Right-hand side, I do that for a reason because it cancels the radical. I get x minus 17. To solve for this x, I would add 17. Why'd I do that? I did 18 for some reason. I would add 17 to both sides. 64 plus 17 is 81 equals x. And then it would want you to check. Let me just plug it into that original equation and then I can send y'all on y'all's way with headaches. Okay, so I do the square root of 81. This is me checking it, okay? I know, and that's one problem. Believe me, I know. I've done them for 12 years, so I don't feel what y'all feel, but believe me, I know. 81 minus 17 all I'm doing right now is plugging everything in. What this equation is telling me, an X value that is a correct answer when plugged into this original, on the left-hand side, I should get 1, and it should say 1 equals 1. So what's the square root of 81? It's 9. And then minus 81 minus 17 is going to be 64. So I'm gonna have equal 1. And what's the square root of 64? And then what is 9 minus 8? So whenever I end up getting, and I know that both examples ended up getting 1 equals 1, you could have a problem where when you plug things in, it's 15 equals 15. It's just the fact that they equal and it's not a contradiction tells you that it's the right answer. Yay, math. Y'all are free to go unless you have questions. Oh. These were my favorite. I'm not even lying. These are my favorite. Like, but it's just like after a while, when I see the life just drain from everyone, I'm like, man, that makes me so sad. Yes. You're good, right? Like you done, yeah. I didn't think you're having a problem or anything. That's me. He's like, I'm already gonna tell you what my grade is. Thank you for helping me. I'm human too, man. Y'all don't let me mess up that long because I'll realize it, but I don't want to realize it so late that like instantly y'all are like, well, forget this, you know? Don't, yeah, like just tell me immediately. Be like, ma'am, you just broke math.